Welcome back, Hononegah, Algebra 1, Chapter 11 Review Guide. This is officially the end. This will be the last video that I do for this school year. We're reviewing all the material from Chapter 11. And so Chapter 11 has kind of a hodgepodge of information. So we'll go ahead and get started here. Here we go. Find the mean, the median, and the mode. So if you want to find the mean, you're going to add them all up and divide by how many there are. And so I went ahead and calculated this. So I added them all up, divided by the number of numbers that there are, and this ended up being 15. I'm going to go ahead and show median now. You have to put them in order from smallest to largest. So 13, there's actually 4 of those. We'll talk about that in just a second. There's 2 14s, so 2 of those. A 16, an 18, and a 21. There's 9 total numbers, so 1, 2, 3, 4, 5. The 5th number is the middle number in between the whole data set. So the median is 14, the number in the middle. And then the number that occurs most often, remember when we just did that data set, we saw there was 13 that happened 4 times. So that is the mode. Finding standard deviation, and I'm going to go relatively quickly here, but to find standard deviation, you put all the numbers of your data in the first column. And so this is what it's going to look like on your test, is you are going to see a column in which you are trying to calculate standard deviation. Next, you have to find the mean. So off to the side, or pause it for a second. You're going to add them all up and divide by how many there are. And so when I added them all up and divided by the number of numbers that there are, I got a mean of 84. I go ahead and write it in every time. There are people that get lazy and just write 84 and then an arrow going down. So the next column, you're going to subtract column A minus column B. So again, going relatively quickly here, column A minus column B. And then you're going to square the third column. So now 4, 9, 64, 324, 256, 64, 1, 9, and 1. So now, average, so take this last column, add them all up, divide by how many the numbers are, and then you want the square root of the average. So I found the average, did the square root, and ended up getting a standard deviation of 9.02. Range is highest to lowest. So the biggest number in this data set is 100. The smallest number in this data set is 66. So the range is 34. The table shows the average lifespan of animals. Find the mean, the median, and the mode, the range, the standard deviation of the lifespans for the given animals, and then identify the outlier. So let's start with mean. You're going to add them all up and divide by how many there are, and so the mean is 12. Put the numbers in order, find the number in the middle. 11 ends up being the number in the middle. Mode, there's only one number that happens more than once, so the mode is 4. Range, highest number to lowest number. So the range, the highest number is 28 and the lowest number is 4, so the range is 24. Now off to the side, I'm going to actually calculate standard deviation by hand. So I'm going to take each of the numbers in the first column. Off to the side, we did find the mean to be 12, so that's the next column. Subtract the 2 columns. And I know I'm going very quickly here, so you may want to pause the video to go ahead and catch up with me. I'm then going to square each one of these. And now, take the last column, add them all up, divide by how many numbers are, and then do the square root of that. And the standard deviation for this is 7.89. The outlier, you'll notice that the lifespans all are around 7, 4, 13, 17, but this cobra is much higher than everybody else. And then let's talk about what if we even added something like a catfish. Catfish has a lifespan of about 60 years. So if it is included in this data, how would it affect the mean? How would it affect the median? And how would it affect the mode? Well, there would be no effect to the mode. Because if you add one more number that's basically a singleton, it would not affect it at all. The median, it would change the median one value greater. So it's going to move this up by one number. And then it would greatly affect the mean. Because all of a sudden now you're adding something that is quite older than the rest of them. So the average of the years of the lifespans for these particular animals would change dramatically as far as the mean is concerned. I'm told that the mean is 8, and I'm missing one number. So how do I find mean? Well, I add them all up and divide by how many numbers there are. And I'm told that that is equal to 8. So now, adding all those up is 38. And solve, x would need to be 10. Apologize for the slight delay there. So next one, I'm told that the median is 12. And so the number in the middle, so I know that the number right in the middle is going to be 12. What would x have to be in order for that number to be 12? Well, if this one's 10, this would have to be 14 to create a median, or the number in the middle, to be 12. Mathematically speaking, if you wanted to do it this way, 10 plus x is equal to 24, multiplying both sides by 2, and x would have to be 14. So the average of the two middle numbers, meaning that number would have to be 14. Box and whisker plot. So they're giving you a box and whisker plot and asking you for some of the values. So what is the least value in the picture? 5. And what is the greatest value in the box and whiskers? 15. First quartile would be 8. The median of the picture would be 9. Third quartile would be 12. And the range is the difference from the highest to the lowest. So again, given a box and whisker, telling me which one each one there. Now we're going to actually have to make a box and whisker. So I'm going to put these numbers from smallest to largest. So 19, 22, 26. Oops, I missed one there. Let me start over again. 19, 22, 24, 26, 44, and 50. So on my number line here, I'm going to start at the bottom, make a tick mark of 19, and then I'm going to go in increments of 5. So I've got 24. Actually, let's do it this way. Sorry about that. Let's start off below it. So 15, 20, 25, 30, 35, 40, 45, 50. So I just made a number line that fits all the data. Smallest number is 19. So I'm going to put a dot here about where 19 would be located. Largest number is 50. So there's my line going across. Now I need to find the median. The median in this particular question is 25. So there's the median, 25. What is the median then of the lower part, or the lower half of this data set? 22 is the median of the lower half. So here's 22. Here's 25. This one's 19. This one's 50. And then the median of the upper half would be 44. And then that's the box. The table shows the weights in kilograms of sumo wrestlers, and they're giving you the first interval. The first interval is from 127 to 142. So now, keeping with the same interval each time, so again, a difference of 15 each time. So 143 to 158, 159 to 174, 175 to 190, and 191 to 206. Now, I've already done this, but I've gone through each one of these and calculated how many fall within each interval. So you may want to hit pause right now, because I'm going to put the answers up relatively quickly. So you're going to go through each one of these and place it into frequency. And I'm back. So there's 8 numbers that fall in the first interval. There are 7 that fall in the second one. 2, 2, and 1. So now, they already have this set up for me. I've got 127 to 142, 143 to 158, 159 to 174, 175 to 190. And then the last one, I know I didn't really make myself much room, is 191 to 206. And so now, 8 for the first one, 7, the second one, 2, 2, and 1. So a histogram. Answering some questions about our histogram now. Describe the shape of the distribution. You'll notice that there is a bunch of information on the left, so therefore this is considered skewed to the right. It's the mean, the median, the better choice. If something is skewed, you'll always use median. If something is not skewed or symmetric, you'll use mean. Is the standard deviation or a 5-number summary the better situation here? If something is if something is skewed, you're going to use a 5-number. Hold on one second. Number summary. Describe the shape again. Symmetric, skewed. This one's definitely the left, so it is skewed to the right. Next one is fairly symmetrical. I know some of you might argue about the one on the right here not being downward, but I'm going to consider that symmetrical. And this one definitely is skewed to the left. All right. Last one. You conduct a survey. Actually, not the last one. I'm getting close, though. And we're back there. All right. You conduct a survey with 350 students in your class to tell whether they prefer pizza or chicken at the school lunch. 189 males responded, 95 of which prefer pizza. So I've got 189 males total, of which 95 prefer pizza. 52 females prefer chicken, so 52 females that prefer chicken, and there's 350 total students that we talked to. So now, filling in the missing information as we go here. So 94 males had to say chicken to get a total of 189. Of the females, now going across here, 146 had to say chicken, adding up those two. And I should have probably switched the colors here. 189, 350, so then 161 had to be female. 109, and then going across in the column, 204. So again, filling in the information. Now, make your joint marginal frequencies percents round to the nearest tenth. So now each of the columns is going to be divided by the total. So each of the cells is going to be divided by 350. So 95 divided by 350 is 27%, and 31%, 58%, adding those up going across, 27%, 15%, 42%. And now for the grand total, you're adding up the column, 46% here, and 100% total. What percent of people surveyed are females that prefer pizza? So again, females that prefer pizza would be 31%. Finish the table again. So again, you're filling in the information from what you know. So females, 112 total, 24 said no. That means 88 had to have said yes. Going down, 38 and 88 add up to 126. That means this number had to be 70 going across. Now going upward, 24 and 46 add up to 70, and then 38 and 46 going across adds up to 84. So you're filling in the missing information from what you know. Identify the total number of females who plan to attend the school dance. So females that attend the school dance, 88. Now, what is the percentage of people surveyed are males that said that they not no to attending the school dance? So now you're talking about males out of the total. So you're talking about 23%, which is 46 divided by 196. Qualitative versus quantitative. Quantitative is when average makes sense. Obviously, qualitative then, no average. So here we go. Brands of athletic shoe. Finding the average does not make sense. So that is qualitative data. Nations competing in the Olympics. Again, qualitative data. Snowfall. Average snowfall makes sense. So quantitative. And average temperatures make sense. So we're talking about quantitative data. Choose from bar graph, circle graph, line graph, or histogram. Distribution of teachers by age. So now, you could probably make an argument this is not over time, so that doesn't make sense. You could make it as a circle graph, but probably this one would be a good one for a histogram. Okay, because you could use intervals. So many in their 20s, so many teachers in their 30s, so many teachers in their 40s, so many teachers in their 50s, and so on. Number of students in the marching band each year. So anytime you're talking about something over time, you should always use a line graph over time. That is it. Hopefully, you're going to take your Chapter 11 test. Hopefully, you'll do well on it. I really miss everybody. I hope to see everybody in the fall. If there's any questions or if there's anything that any of your teachers can do for you, I'm sure they'll help you. Good luck and have a great summer.